This is going to be a bit of a niche video. This is specifically for people that are wishing to compile the Amazon Web Services C++ SDK and are using Visual Studio for that. There's lots of other things this could be compiled for. You could be compiling it, say, for ARMS, for the Android SDK, or for something on iOS or for Mac. But I'm specifically looking at this scenario of someone that is on Windows, they're using Visual Studio, and they want to compile the C++ SDK. If you're doing one of those other variations, then this video will not help you. Now, I am setting up a new machine, and in setting up this new machine, I want it to be as similar as possible to any of my other development machines. So in furtherance of ensuring that I am consistently setting up machines, I have scripted my process of doing certain things, including installing the AWS SDK. So the script that I wrote, which is just pretty much just one batch file, this is all that you need. If you were to go to this repository, and if the only thing that you downloaded was this batch file, you could get the AWS SDK compiled and running just by typing a single command. Now, when you type that command, you do have to do it from a Visual Studio command prompt, which if I go into Visual Studio 2022, there's a subfolder there where it shows the various command prompts. You would just take the regular one, and that is what you would run the script from. I do also have documentation to go along with this. It is both available here within the README file for this folder, but it is also available on my blog, and the contents of both are dang near identical. So you could go to one or the other. And I will make sure this video is linked in both of them. For someone that's using my script in order to build things themselves, there's a few things in a script that you'll probably want to change. You may want to change the drive to which you're cloning. I've checked it in, so it's cloning to the C drive. On a machine in which I actually install this, I'm cloning it to either the B drive or the D drive. I can't remember which. But you want to specify the drive and then the path on that drive to which the clone folder is going to go. And after it gets compiled, you want to specify the drive that you want it installed to, and then the path where the installed files are going to go. After you have customized both of those for yourself, you can run the batch file from the Visual Studio Development command prompt. All the other steps that it takes for performing the compile, you will find within here. So it will take care of making these folders. It will clone with recursively, and then it'll start the build. It builds 4 times. And the reason it builds 4 times is there's different types of builds. So for debug mode, there is what we call the shared project. And this one produces DLLs so that your program can dynamically link to it. And you have to make sure that you distribute those DLLs along with your program. There's the debug static build. And with this one, the Amazon functionality is going to get attached to the same binary that all of your code is in. So you don't have to make sure that you also distribute additional DLLs with it. And then you'll find the same thing for release mode. So there's a release static build, and I need to change my labels on here because one of these is for the release static build and the other one is for the release shared build. This one is shared, so I will make sure I get that change. Actually, we can go ahead and do this right here in video. So it's going to do all 4 of those builds, and let me show you what the output looks like, or at least a part of it. And so within the output, I have the 4 build folders. If I go into any one of these, all of them will have the include folder, which contains the AWS headers. Just backing out of that. And then for the static folders, for both the static and the shared, you'll find a folder that has the libs that you want to attach to. Let's see, this one is in the shared, so there's also libs that are within here that correlate to each one of the DLLs that this uses. And there's the DLL. So if you use this, and if later on, if you wanted to update an application, instead of having to recompile the entire application in order to get updated AWS DLLs, you just be able to copy the DLLs out. Looking in a static folder, you can see that this has less within it. You don't have the DLLs to distribute. What you do have is the libs that have the same functionality that was in those DLLs within it. And for the release folders, you will find the more or less the same structure within them. Now, if you choose to use my batch file in order to build the AWS SDK, the only thing you actually need is the batch file itself. So you could just save that from GitHub, and that's it. You've got everything that you need from me. I did include a sample project within here. There's actually 2 sample projects. The thing is, these projects, they don't actually do anything. They're not here to do anything other than to just serve as a piece of code that you can try to compile and see if you have everything set up correctly. If you do have everything set up correctly, then it should compile without errors. If you've missed a step, if something's gone wrong, then it won't compile. So let's open this one. This was a minimalistic AWS project. Upon opening this project, the first thing that you notice is that it doesn't seem to be able to find the include files. Okay, so in order to fix this, this has a path from the other machine in which I was using a B drive. I need to change this from B to C. Everything else in this path should be correct. And that's the path that you'd use on your machine too, assuming you haven't changed anything in the script. And so now that I've made that change, we can see that those errors are gone. It's able to find them. If I try and compile now, I'm still not expecting this to work. So yes, it didn't work because it tried to attach to the first lib, it was unable to find it, and so it errored out there. If I were to just fix that one, then it would actually do that for each one of these. So similarly, if I go back into the properties, this time it's going to be within the linker. And additional library directories is what we're concerned with. And you can see it's the same thing here. So if I go into this, and if I change it to C, and try to compile things now, this time it compiled. Now the thing about using the static libraries is if you do that, you're not going to have to distribute the DLLs with the project, but you also need to make sure that you link to every single thing that that project is going to need. And so you can see from the AWS side, that is a lot. Instead of statically linking to these, if I did dynamic linking, then I don't have to include all of these, but I do need to make sure that I include the DLLs that have these various names within them. Let's say that I want to change this from being dynamic to shared. So there's a couple of things that I need to do. So select this, I'm pressing alternate and enter. And we're going to have to change these paths. So on the linker, let's do an edit. The name of the folder I should be linking to if I wanted to do the shared is Debug shared. Now I could probably get away with not updating where it's pulling the headers from. I haven't actually validated though that these are the exact same, so I'm not going to try and do that here. We're just going to make sure that it is also pulling from the headers that are in the shared version of this build file. So we don't need to link to all of these AWS items anymore. And some of these things I was linking to because the AWS thing requires them. I'm not actually calling them here. So I've essentially removed all of those items. Now I still expect this to fail, but let's compile it anyway. Yep. So this failed. It is still trying to statically link to those files. So what I need to do is just use import export. I made sure that it was not defined in the project previously. Now what I want to do is go ahead and define that, and we're going to define it, we're going to see it compile, and then I'll explain what this does. I am going to explain this now instead of explaining it later. I've chosen one of the headers here, and you'll see this pattern throughout many of the headers. Whenever you are importing a function from a DLL, in its declaration there's a certain prefix that's necessary, and that is this prefix. If we are statically linking, then you don't use that prefix. When you define use import export, it changes how these preprocessor definitions get handled. If it is defined, then ultimately it's going to result in this prefix being used anywhere we have AWS Transfer API. If this were not defined, then AWS Transfer API ends up being defined to equate to nothing. So we can go ahead and put this as a prefix on any of the functionality, any functions within this library. And the effect that it has is going to be dependent on whether or not you use import, export was defined. Now, I am using this one header file as an example. You will find many other header files that have this exact same structure, only it might be some other variable that has this preprocessor logic that's defined. The reason we had to define this before we import those headers is so that it will have an effect on them. If we define it after we import those headers, then it is not going to have the intended effect. Now let's go back to the main video. So compiling it now. Okay, what am I missing? I am missing something. Now I'm still going to need to link to some of these AWS headers. Let's see, which ones am I actually using? I think in this project I make a reference to the core. I made a reference to S3. And then there's one other one, I believe, Zero Transfer. There it is. So since I'm referencing these functions, I can get away with only including these libs, but these libs will take care of actually dynamically loading the DLL. These are not the libs that have the actual functionality within them. And so I see the other mistake I've made. Let's see, we need to go to the linker. Here's something that I forgot. This is the wrong path. So I do want to be in debug shared, but in debug shared, it's not the lib folder that I want to be in, it's the bin folder. They put the DLLs and the libs in the same folder for the shared. Compile now. I know what that is. Okay, there we go. So I accidentally included the wrong folder with the the wrong lib with the S3, but now I have the correct one included. Now that I've built this, it's going to compile, but I don't expect it to actually run. So let's go ahead and hit the run button. And even though this program isn't really doing anything, I still expect it to fail. And there it is. So you see it's failing because the DLL is not included here. So now onto the next step of fixing this. If I go to the folder where I have everything, this is where the output is. So we have our executable there, but none of the DLLs are here. I'm going to take the lazy way out. So this is the debug shared that I'm working with. In debug shared, if we go into bin, if I were to copy the DLL that it complained about over, then it wouldn't error out on that, it would error out on another DLL. And it will keep doing that until I get the correct set of DLLs installed. The actual list of DLLs that I need, I actually did enumerate them here. So these are the DLLs. Now, if I were trying to be efficient, I would just go and copy those specifically. I am not trying to be efficient in file size right now, but being efficient for time. Let's see, organize these by type. So now all of my DLLs should be at the top. I'm going to copy all of these DLLs. I don't need all of these. Like I said, I'm not trying to be space efficient right now. But in the interest of time, I'm just going to copy all of these over. So now that I've made those changes, if I compile, it's going to run. Now remember, I said this doesn't actually do anything. In my main function, you can see all I do is I initialize the SDK, and then I shut it down. And I never even call this function right here. This function only exists so that it is trying to link to some other AWS functionality. But we run it, and this time it started up without complaining. So it's actually able to find the DLLs that it needs. So if I just let it step, so it successfully made a call to initialize, it successfully made a call to shut down. So now I am linking to the AWS source code. I'm going to leave this as its own video. When I was trying to figure out how to compile the AWS CPP SDK myself, there are some challenges I ran into, and there are some other people I found that ran into some challenges. So I thought it might be useful for those people just to have a video that talks about nothing more than getting the SDK compiled. So that is what this video is. Now I plan to come back to this because I've already written something else that is using this, and that's going to get its own video. Like I said before, this is kind of a niche topic. It's not something that I think is going to be of general interest, but For those of you to which it is of general interest, let me know. Say something in the comments. I hope you've both enjoyed this, and I hope this was helpful to you. I do have another project that I'm working on right now that is using this, and I plan to make a post on that within the next couple of weeks. So if you want to see that, head over to j2i.net within the next couple of weeks after I've published this video. Until next time.